everybody, this is Mrs. Palyuka again. I'm going to do a supplemental video on ordered pairs. This does follow the lesson module that you need to do for week 4. You should not watch this video in lieu of, that means instead of looking at the lesson. It's just as either a preview or a recap before you take your quiz. All right, there's 3 objectives that they listed in the lesson. So the first one that we're going to go through is I can recognize the signs of coordinates in an ordered pair or compare 2 ordered pairs. So that's the first one that we're going to be talking about. So an ordered pair is always going to be exactly what it sounds like. A pair of numbers that is in a specific order, in the order of X, Y. Think of in alphabetical order, X comes first, then Y, so it's always going to be written in this format. So if you have an example such as the ordered pair 5, 4, you need to be able to recognize the signs of these numbers. Well, since there's no negative sign where the 5 is and there's no negative sign where the 4 is, what we can say is that our X value is positive and our Y value is positive also. Here's another one. In this second example, the ordered pair -4, 3, our X value is negative because of this sign right there. Our Y value is positive because notice that it's just a +3 written there. And our last example, we have the ordered pair 3, -2. So on this example, we have our X value is positive because this is our X value, and our Y value is negative because of this sign right over here. So when you're asked to be able to determine the positive or negativeness of the X, Y values, you're really just looking for those signs. So the second part of the objective is for you to be able to compare 2 ordered pairs. Now, when you're comparing things, just think of, you're always thinking of the same 2 things. What is similar or what is the same and what is different? And that's really all that you can do with ordered pairs. So I've listed 2 ordered pairs here, the ordered pair -7, 2 and the ordered pair 7, 2. You'll notice the first ordered pair has a negative number in it, which is right here, but the second one does not. So the one thing I like to do again is go ahead and write down my ordered pair X, Y. I'd just like to see those letters. And I'm going to rewrite these numbers one above the other because I can compare easier when one thing is written above the other. So here I've got my 2 ordered pairs written again. So when I'm looking at this, I see I'm comparing my X's and then I'm going to compare my Y's. Well, I want you to look at the X's. The X's on one of them is negative for the -7, the other one is a +7. If you're looking at your Y's, they're both the same. So here you can see how I kind of broke them down vertically. So when you're comparing these, there's not a whole lot you can kind of say. You basically can just say that both points have different X coordinates. That means one's positive, one's negative, but their Y coordinates are the same. So let's move on to the second objective listed in the lesson. This says, I can indicate in which quadrant of the coordinate plane the ordered pair will be located. So it's important to understand a coordinate plane. So it is made up of a horizontal number line, so you've got one that goes from left to right, and a vertical number line, one that goes up and down. And what you're doing is you're overlapping these. You're putting one on top of the other, and they're going to match up where the zeros are. So over here, okay, you can see that I've got a coordinate plane. Now you don't see all the grid marks, but this is just for us to figure out our different quadrants. There's 4 different quadrants. Now I went ahead and labeled the origin, which is in the center. That's where 0 would be on each of the number lines. So we've got quadrant 1, which is at the top right-hand corner, quadrant 2, which is at the left top, quadrant 3 is the bottom left, and quadrant 4 is the bottom right. I went ahead and used Roman numerals. The video module lesson used both Roman numerals and regular numbers, but I'm just used to using Roman numerals, and so that's what I'm going to go ahead and use today. But they're named the same thing, 1, 2, 3, and 4. So here's my X axis that I just labeled in bright pink, and here's my Y. So when we're talking about quadrant 1, all right, so when you're graphing something, you're always going to travel to the right or left first. So you're traveling the X line. Now remember, ordered pairs go in the order of X, Y. So you always want to walk to your X number first, and then you're going to climb to the Y number. So on this one here, in order for us to have a point in quadrant 1, we're going to have a positive X value, which means we're walking to the right, and our positive Y value tells me we're going to be climbing up. So think about the number lines that you guys practiced with the last 2 weeks. Positive numbers are to the right or also up above the 0. Then we have quadrant 2. So in quadrant 2, this time what's going to end up happening is you're traveling to the left. Well, to the left of the origin this is where your negative numbers are. So you've got -1 right over here, you've got -2, -3, -4, and so forth. But in order to be up here in this area, oops, let me go back. I pressed the wrong button here. Bear with me, guys. There we go. So in order to be in quadrant 2, we have to travel to the left first, which is negative, and then up. So quadrant 2 has a negative X, positive Y. Quadrant 3, all right, we have both negative values because you're traveling to the left, and then you're traveling down for quadrant 3. So when both your X and your Y numbers are negative, you know that you're in quadrant 3. And lastly, we've got quadrant 4. Both numbers, you've got a positive X, that means you're traveling to the right, and then you're traveling down to go to your negative Y. So we're going to go through a couple of examples now. So at the top of the screen, you'll see the ordered pair 4, -4. Now remember, this is our X axis, and this is our Y axis, the vertical one. So if I've got the ordered pair 4, -4, I'm going to be traveling to the right to the 4. So if I'm going here, this is where the 4 would be, where I put this very small little red dot or pink dot, 1, 2, 3, 4, and then I would be going down. Now we're not practicing drawing these ordered pairs today. What we're trying to figure out is what quadrant this ordered pair would be in. So if we're walking to the right, that's our positive motion, and then going down because of the negative, I'm going to be somewhere in this quadrant here. So if you think about the quadrants, remember, it goes quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So the answer for this one would be this point is located in quadrant 4. Let's try this one again. Our next example is the ordered pair -7, 4. So the X value is negative, which means we're traveling to the left, and the Y value is positive, which means we're traveling up. So therefore, that falls in quadrant 2. Our third example, the ordered pair -5, -9, they're both negative. So that means I've got to travel to the left and down. This is quadrant 3. And the last example is the ordered pair 6, 8. Notice both numbers or both values are positive. So in order to travel to a positive area, we're traveling to the right, and then we're traveling up. This happens to be quadrant 1. All right, so we've got one more thing to go through. Now we can determine the relationships about how ordered pairs are reflected across axes. So if you recall, during the video we discussed, or during the lesson module, they talk about mirror images. So when you're looking at your reflection in the mirror or across a pond in the water, if you wave to yourself with your right hand, the image is waving back to you, but with the left hand. So you want to keep that in mind. There's going to be some oppositeness of this. So we've got our x-axis and our y-axis labeled here. So if we're reflecting across the axes, let me explain what that means. Let's say I have an ordered pair or a point up here in quadrant 1. So I just put a star there. If I'm going to reflect this across the x-axis, I think of it as if I'm jumping across the x line because I'm reflecting it across the x-axis. Imagine that's where your mirror is. Well, your image is going to be on the other side of that mirror. Okay? So let's try that again. Let's say we're down here in quadrant 3. And I want to reflect across the x-axis. Well, this is my x line right here. So if I'm going to reflect across the x-axis, it's as if I'm jumping, or this is where my image should be on the other side of that x-axis. Right? If we're doing this with y, reflecting across the y, let's say we're down here, okay, and I want to reflect across the y. Well, here's my y-axis. I'm going to jump over that y line. So therefore, I started in quadrant 4, but when I reflect my point, I'm going to end up in quadrant 3. All right, so let's try these with some specific ordered pairs. So here I've got a picture of a grid. So we're going to go ahead and practice a couple with reflecting across the x-axis. Now you can see that this is labeled right here. This is your x-axis right there. So if I have the ordered pair, and of course I always like to write xy, the ordered pair 5, -4. So if I plot the point 5, -4, I'm going to walk to the 5, so that brings me right over here, but then I'm going to go down to the 4. So this is where that dot would be right there. So if I'm reflecting across the x-axis, this is the line that I'm jumping over. That means my dot has to be up here in this quadrant. Okay, so here's what I like to do. If you're reflecting across the x-axis, you end up, and directly underneath it, you end up keeping the same x value, but it's your y value that becomes the opposite. So it was -4, and now it's going to be a +4. And let's think about that. So if I keep the ordered pair, 5, -4 is, we plotted that right down here. So if I'm going to plot the ordered pair 5, +4, I'm still walking to the 5, I'm going up to the 4. This is the new location of my dot. That's exactly where it should be. If I accidentally put it down as a -5, then I'm going to end up all the way over in this area here, and I don't want to do that. So we're going to go through another example. So here I've got the ordered pair -3, -4. So if you want to visualize where this ordered pair would be, I'm going to walk to the left to the -3 and go down to the -4. This is where this point would be. Since I'm reflecting across the x-axis, sorry, that was the wrong one. If I'm reflecting across the x-axis right here, my answer is going to have to be up here in quadrant 2. So if you think about what I mentioned before, if you're reflecting across the x-axis, you're going to keep the x value the same, opposite y. So if you're reflecting across the x, keep the x, do the opposite y. So think about this. The ordered pair -3 brings us this way, and +4 brings us up, and that's where this guy would be right over here. And that is definitely reflected across the x-axis. Okay, let's do one more. We now have the ordered pair 2, 1. So if I just use the numbers, let's think about this. I'm still reflecting across the x-axis. I want to keep my x opposite y. In this example, my ordered pair for the reflection would be the ordered pair 2, -1. I kept the x, but I used the opposite y. So let's do a couple of examples now where we're going to reflect across the y-axis. So here's our first one. So if we have the ordered pair 3, -3, I'm going to, I'd like to write down my ordered pair here. Since I'm reflecting across the y-axis, I'm going to keep the same y, but I need the opposite x. The opposite of 3 is -3. So originally, our original point will be right over here. That's our original point. If I reflect across the y-axis, which is our vertical one, then I end up over here. And that looks like I went in the correct direction. Our next example, the ordered pair -2, -2. Again, sometimes I find it easier just to write my brackets with my comma down. If I'm reflecting across the x-axis, I'm keeping the same x number, opposite y. I'm sorry, I said that wrong. Scratch that. If I'm reflecting across the y-axis, I'm keeping the same y number, opposite x. So opposite of -2 is +2. And our last one, again, we're reflecting across the y. So I'm going to keep the same y. The opposite of -4 is +4. All right, so those are the objectives that we had to cover in this lesson, so hopefully that helped. If you end up needing more help, guys, you can always reach out in discussions. There's always a teacher monitoring those, or join a Zoom. We have Zoom lessons planned Monday through Thursday every day for at least 2 hours. I think on Mondays we've got 4 hours of Zoom on there, so check the announcement board.